Alright, so in this video lesson, I am going to introduce an example that brings up an application of definite integrals. But aside from that, this application also brings in the concept of finding area in calculus, and we're going to apply that into business field and economic studies right there. So needless to say, this video lesson is intended for the students, calculus students who are on track to business field, in particular in economic studies. Okay? And so I highly recommend viewing this video after you have watched my general lecture regarding definite integrals. And so among the lesson there about definite integrals, I talked about how integral is used as a tool to find areas, any area between any two curves, and finding area was indeed in a way how I introduced it, the problem with the definite integral, and finding area was a very ancient math problem, but surprisingly it has a large application. And so once we came up with the idea of taking the integral, then we use integral as a very effective tool to find areas that's being trapped between two curves. Okay? And so we learned that, but back in the lecture about learning how to find areas between two curves, those examples we did there were simply just some math problem that we find the physical areas. But now for us here, for the viewers of this particular video here, why are areas so important for us? Why is the skill of being able to find areas between the two curves here important for us? And where can we see the applications of finding area between two curves in our work in the future? Because think about it, later on you're going to be a business leader, you're going to become an economic analyst in any kind of a career path like that that's in the business field. And so what can this skill about finding area between two curves do for you? Okay, and so let me now bring up specifically a little bit of talk about why this area problem matters in your field later on, and then from there I'm going to actually show the examples again. So in your understanding at this point, and allow me to go just brief because I want to leave all that full and complete understanding for your econ or business professors to explain all of these concepts. I'm only going to bring out these concepts that you have seen prior to entering this class, I believe, and then we're going to, on top of that, we're going to do the math part of that. Okay? And so now I'm pretty sure anyone arriving at this video and learning in this course here has already understand what it means by the demand curve, okay, and the supply curve. That's also a big concept to be highlighted in business, right, or in business and economy. Okay, demand curve and supply curve, right there. And so what exactly these are, again, I said I want to leave that for your professor at a formal econ course or business course to explain what those are for you. Here I'm just gonna mention that, and so that you can bring in your own understanding regarding demand curve and supply curve, and then we're gonna start seeing this completely. We're gonna start investigate these curves here completely mathematical. Okay, and so it's a function. It's a relationship between. See, the demand curve relates between price as a letter P and Q for quantity, and many times it could be optionally X instead. Okay, so quantity can be interchangeably used as Q or X. The same thing with the supply curve. It's a curve that points out the relationship between price and quantity, or as a variable's name, sometimes some textbooks use X right there. Okay, and I may use X as well. I may use Q. It's all the different variations of the quantity variable. So demand and supply curve, both of these curves are the curves that relate between price and quantity. That's and this is about the most detail I can go for now, because again I want to leave that full complete understanding for your econ and your business instructor to mention to show you. And so now, let me switch over to the graphing calculator on decimals of mine, because I don't want to do a hand sketch version here, making it a little bit so doing a hand sketch is not going to be as nice as the one I'm using with decimals here. So now with my decimals prepared here, let's say we have a demand curve, and it's not always, but usually enough, commonly enough, the demand curve is usually a curve that's decreasing. Okay? And so there's our demand curve, and whatever function for this curve, that's not the big point of concern right now. It's just here we have a demand curve. So guess what? The vertical axis here is the axis for pricing, and then the horizontal axis here is the axis for quantity. So you can name this the x variable, or you can name this horizontal axis the q variable if you want to. But very common that we name very commonly that we name the vertical axis here to be the pricing. So the letter P is for this, the vertical axis. And so that's the demand curve. And as I said, usually it's a curve that's from the left to the right. It goes decreasing. Okay. And then on the other hand, so now the curve in blue that I just now brought up is we can think of that as the supply curve right there. And so the demand is in red, the supply is in blue. Okay, and demand and supply are always two important curves that anyone studying about business, you need to know this and how to operate with this. And so demand and supply, we always, you see, because due to the nature that they're going in the opposite way at some point, one of them is dropping down and the other one is pointing up. So they will cross their paths at a certain point. Okay, and that point here, we refer to that as, now again in a formal term, it's the point of equilibrium. Okay, it's the equilibrium point. And so again, I only mentioned the name here, but I just want to leave that for your instructor, your econ instructor, or your business instructor, your professor, to explain what that is. And so that's what it is generally. Demand, price is going this way, quantity is going this way, x, I use x for my variable here, so x is going on the horizontal side. And so pricing, demand goes down, but supplies go up, and they cross path at that point right here. This point is where we call the equilibrium. Okay, and so what exactly that is, I'm gonna, as I said, I'm gonna leave that for your instructor to explain that. But you see, so in the end, as a graph here, it's a two-dimensional graph. There's one axis for the quantity and there's one axis for the price right here. So one point itself is a combination, right? And this is, so mathematically anyone knows that on a graph a point is a combination of two values. So the x value here is the quantity, and then the pricing is the vertical coordinates right there for that. So just like that, that's why now back on my precise graph on the decimal screen here, then see, now let me really pull out my equilibrium point. All right, so there we go. My equilibrium point is right here, and allow me to not really show the actual value for these, because I don't want any viewers to be worried about any of those yet, because I didn't even show the actual graph for this red demand curve and the actual the function for this blue supply curve. We didn't need any of that here. We're just looking at the general idea here. All right, so that's all you need to know right now. And of course, this is nothing unfamiliar with any of you viewing this video lesson. And so the demand is here in red. The supply curve is there in blue. And so this point right here is called the equilibrium point. So that particular x value here is called the equilibrium quantity. Okay, equilibrium quantity. And so on the vertical side, it's a price. So the pricing right here is called equilibrium price right here. Okay, so it makes sense enough with those terms right here. So now, allow me to bring in another very familiar concept that anyone, believe me, anyone who has already arrived at this video lesson should have learned that in some of your past course, even long before you entering a business calculus class here. And so the terminology that I'm about to bring up, that I'm about to bring in, is the concept of consumers surplus. Okay, and producers surplus. All right. So these two terms, again, I want to leave that for your formal econ professor or the formal business professor to give a nice, full, complete understanding of that. Okay, so here I'm only bringing up these terms here and assuming, and allow me to assume that anyone viewing this video lesson already have a good, clear understanding of what consumer surplus is, and what a what's producer surplus means. Okay, but now here's the part I'm bringing in right here. So I'm going to show you graphically how this thing appears on your graph, and I'm pretty sure you have seen that in your econ study and your business study as well. But here, mathematically, this is the part where we can I can speak here strictly in terms of math right here. So let's look back at our demand and supply graphs together. So one graph has two curves, the demand curve and the supply curve right here. So you see this line, that's why I'm putting that in dotted line right here. This line right here, right, horizontal line right at the equilibrium price right here. So all of that shaded area between the red curve, the demand curve, and this line right here, where our pricing level is, all of that area there is the amount of what we so call the consumer's surplus. So the consumer surplus, in your own understanding, now you apply that into the math concept right here, then that is represented as the area shaded, but only from this line up to the graph. Okay, and so all right, so here we go. Let's have a view at that. All right, so the shading area that I just now brought up right there, that shaded area is how about let me change that to a different color choice right there. So not convincing enough for that color. Okay, so right there. So that shaded area here represents the consumer's surplus. So it's the area that's only shaded from the equilibrium price up to the graph of the demand right here, and it stops right at that equilibrium point, and that area there is the graphical representation of our consumer's surplus. Okay, and so another minute to allow me here another minute that I need here to prepare a different graph right here. All right, so here we go. That area here, and how about in a different color? All right, so in blue this time. Okay, so the area in blue below the equilibrium pricing, and so basically between the equilibrium pricing line and the supply curve right here, that area in blue right here is the graphical representation of the producer's surplus. All right, so we have two areas here representing the two concepts that anyone should be familiar with at this point: consumer surplus and producer surplus right there. Okay, and that's why finding area problems exist right in your business application. That kind of problem stays right there in your business application. Okay, and so we're going to keep that graph there, because now see this area in pink right here is the area between a curve between that curve in red and this line here as a secondary curve like that. So we got a curve and we know which one is above and which one is below, and then the blue area, to find that, once again we can identify that we have an interval from 0 to wherever that equilibrium quantity is, and then we have a curve above and we have a curve below, and we can find the area between. Okay, so all that here now I'm going to start bringing up all of your, I'm going to start blending in your understanding with using integrals, definite integrals, to find an area into doing this real application right here. We are finding surpluses. Okay, consumer surplus and producer's surplus. Okay, And so now that's enough with the general discussion. Okay, so let's get straight over to our particular example here. So I'm setting up this example here, and again, forgive me for the sketchy description, but it should be descriptive enough. That so what I have here is the demand function, or the demand curve is the function p of x. So here x is my variable for quantity. Okay, so x is the variable of my quantity. So p of x as the demand is this right here, 396.9 minus 0.6x squared. That's my pricing related to quantity as the demand curve. And then on the other hand, I have my supply function. Okay, so p of x equals 0.3 the x squared right here. And so these are all quadratic functions, but they are different functions. And so let's now let's now put a pause on looking at the question in part A. I want to now look back at the graph again. And so now admittedly I have to point out the graphs I have prepared on the screen just earlier. Okay, this graph that I have prepared on screen earlier really was the graph for our two functions, our two demand and supply curves that really came out from this example that I'm currently at. Okay, so this is the graph for 396.9 minus 0.6 x squared here. This is our demand curve that you just now saw on my lecture notes. And then this blue curve right here is that curve for 0.3 x squared. Okay, so this point really is going to be our the equilibrium point that we need to find out what that is. Okay, and so now, so as an essential skill right here, now let's look at our actual first question. The first question is asking us to find the equilibrium quantity. Find the equilibrium quantity. Okay, find the equilibrium quantity. That means we want to find the x values where the red curve and the blue curve meet together. And one more time, let's swing back to the graph right here. Okay, red curve is the demand, blue curve is the supply, and red and blue will meet at some point. Okay, and so we want to find out the equilibrium quantity is the x values right there, and that's what we want to find out. Okay, and so algebraically speaking, to find that equilibrium quantity, or the x values, the x value where our blue curve and our red curve meet together, we simply just need to equate our two functions together. Now our demand has already been expressed as a function price as a function of x. So what I've had here is 369.9 minus 0.6 x squared, and then our supply curve is that p equal 0.3 x squared. Okay, and so to find the x variable here in terms of the quantity, so the two curves meet each other, or the two curves cross each other where we set 369.9 minus 0.6 x squared to equal with 0.3 x squared. That's how we start. So we always going to set the demand and the supply curve equal to each other. And so P1 equals P2, the two prices, because that's where equilibrium market is. Okay, demand and supply meet and agree, on a certain pricing, and that's why we need to set up these two x expressions to equal each other. And here we're going to algebraically solve this equation here for x, because x here is the variable that we want to find a value for. Okay, so it's just going to take a little bit of algebra right here. I'm going to add that 0.6 x squared to the other side to be like term with this, and I'm leaving this 369.9 there. So 369.9 equals, now after adding this over to the other side, I'm looking at 0.9 x squared. Okay, and then I can, and this is only my own route right there. You can take your own what I see here is a quadratic equation, and so you can also have your choice of bringing all terms here and put that into a complete quadratic form and use your quadratic equation. You have plenty of choices here because the viewers, the students for this video lessons, you guys are calculus level math course. So don't get the algebra got you hung up on that. Okay, don't let the algebra get you hung up on that. All right, so I'm going to divide 0.9 and then divide it by 0.9 on both sides right there. So I reduced down to x squared. How about x squared equals 411. Okay, and so this simple quadratic here, we can solve that by taking the square roots equally on both sides. So taking square root, we technically go with plus and minus square root of 411. Okay, plus and minus square root of 411. That's the algebra part of that. But think about that. At the end, we're going to have to take away the negative because the x variable here means the quantity in our actual business application. So we can't have a negative quantity. Okay, and so that's why in that way right here, our final answer here is just the positive square root of 411. And so okay, and I just realized I made a little bit of a mistake here. I wrote down this number incorrectly. And so no wonder why I felt something off with that. So this is 396.9. So this is 396.9, and this is 396.9 right here. Okay, and so this number after dividing should now be corrected to 441. Okay, and now that's making our answer a lot nicer and easier to work with. 441, and so this is now going to be positive 21. All right, so ladies and gentlemen, this is our equilibrium quantity, the quantity that happens, the quantity where we reach equilibrium agreements between demand and supply. Okay, it's the equilibrium on the market. All right, and so now that answers our question in part A. So now let's get ready for the question in part B to find out what part B is asking. All right, so for part B, now let's find the consumer's surplus at the equilibrium quantity. Okay, the consumer's surplus at the equilibrium quantity. Okay, and so same two curves here, the demand curve and the supply curves, they both stay the same, but find the consumer's surplus. And so now this is in this concept that the question is looking for, in this consumer surplus that the question is looking for, then now we need to look back at the graph a little bit. Okay, so when we're looking at the graph right now, then all right, consumer surplus is this area, okay, between this line right here and the demand curve. Okay, and so now here's how we're setting it up. Seeing this as so in the end, we need to know what our equilibrium point is before we can set up successfully our the area calculation setup here. So let's find out what that the equilibrium pricing is, and it appears to be a straight line here. So in that way, let me now swing to my other board. I have found that we reach equilibrium quantity at x equals 21. And so we have two choices. We can either go with P. You see, we have two different curves right here. So when we reach to the equilibrium quantity, then we can substitute that into either one of these two, and we're going to reach the equilibrium price. So among these two, I'm pretty sure that any viewers will choose this one here because it's shorter and it's less calculation work for us. Okay, and so in that way, I'm going to go with equilibrium pricing. Okay, to be correspondingly, so this is how about 0.3 times 21 squared. All right, so my value came out to be, let me do a quick calculation here. Exactly 132.3. All right, and so this is my equilibrium price, and this is my equilibrium quantity. So I just decided to stay with a very simple notation here. Some textbook call this X1, P1. Some textbook call that with so many different fancy names with a subscript E right here. You make your choice on that, okay? So I'll just see this right now. This value 132 here, as it's a horizontal line. It's our equilibrium pricing. So now back on the graph right here, we have an interval. I mean, we have an area that's obviously between two curves. An area between two curves. This area in pink is between the curve in red here and the curve, and this straight flat line, and this line is, tell you what, it's our equilibrium pricing that we have just now found to be 132.3 right here. See, now I can pop out the actual coordinates of that. See, the y value, the vertical coordinates for that point is 132.3, like that. So, and this area is shaded between the two curves. So that starts bringing up a familiar experience like that we have learned back in the lecture about the definite integrals. And then this shaded area is also being between 0 for x and x equals 21. Okay, and so now, clearly speaking, we can start applying our integral concept right here, our definite integral. We can start setting up a definite integral to calculate this area between the two curves, because that's the skill we essentially have already learned back in the lecture for definite integrals. And so now, this curve in blue, this curve in red right here, remind yourself that is the demand curve, which is this curve. And according to the picture that we just now got out of, this curve stays above this line right here. Right? So this is the horizontal line. And the curve we had, so as a quick reconstruction of the figure, 132.3 is about here, and the curve, the demand curve, points out like that. So the area we're trying to obtain is right here, where the interval is from 0 to wherever that is, 21. Okay, and so now realizing clearly what we are supposed to do, we're now our goal here now is to figure out how big that area trapped between the curve and this other flat curve right here. Now we're gonna start setting up our integrals. Okay, so the integral work says in that interval, as a definite integral, then we're setting up from 0 to 21. Okay, in that interval of our integral work, the function that stays above right there or stays on top is going to be our function 396.9 minus 0.6 x squared. Okay, I'm going to need to take that function and subtract 132.3. I just want to make clear about that concept of how we applied it. See, this is upper curve minus lower curve to find the area between the two curves. Okay, and then we're doing that in respect to x right there. This is the x-axis. If it was a q here, then we're gonna do the dq, and our variables here are all the q variable. So it's just the rule of thumb here is we always set our d part of the integral to be consistent with our main variables, and I mentioned that back in the general lecture of the discussion on definite integrals. Okay, so that's our successful setup for the area. And once we're done with that integral problem, it's going to give us the area, how big that area here is, and we call that it's a consumer's surplus. So many textbooks use that CS right there for consumer surplus. Okay, and so now I'm going to erase this here to maximize my board space here. All right, so now I can combine like terms a little bit before I head out for the actual integral work right here. So from 0 to 21, and then all right, so here I'm looking at my final setup here before we really are doing the integral work, to be 264.6 minus 0.6 x squared, okay, dx. All right, so this is the final cleaned version of the integral setup, ready for finding the final area or the final consumer's surplus. Okay, so now here comes the antiderivative steps. We need 264.6 x minus, now taking the antiderivative here is going to give me just now 0.2 x cubed. Okay, and again, assuming that, allow me to assume that anyone viewing this video has already been fluent with how to find an antiderivative in general, and also specifically has already viewed my other video lesson on how to operate with the fundamental theorem of calculus. And now I'm going to evaluate from 0 to 21. And so think about as a far impact for here, 0 substituted in each of the term here, they all has a variable x in here, so that 0 value after substitute will make the whole thing 0 out. And so all I have to worry about is the 264.6 times, be evaluated at 21 minus 0.2 times 21 cube. Okay, that's my evaluation right there. But you know what? See, I changed my mind in case anyone still wonders. So I just want to strictly follow the fundamental theorem of calculus, even though I can already see the result. So 264.6 times 0 minus a 0.2 times 0 cubed. Okay, and that's why I was saying earlier, all this here will quickly become a 0. All right, and so now allow me to quickly step over to my calculator and get a calculation final result right here. All right, so my final answer after working through all of this work right here came out to be, so it's 3,704, and 4.4. Okay, that's our final answer. Okay, and this is called the consumer's surplus. All right, and so now let's look at the next question. So we have found the consumer surplus, and essentially we recognized that the consumer surplus was an area between the two curves. That flat, the area between the dropping down curve and that flat line for the equilibrium pricing right there. Okay, so now back on my lecture notes, let's look at question C of our example. So now we want to find the producer's surplus at the equilibrium quantity. Okay, so producer's surplus. Now let's have a look at our graph here. All right, so I explained earlier the producer's surplus is this blue area right here on our picture. So let's look at the blue area here a little bit more closely now. So it's an area that's being shaded between the two curves. Not the red curve and the blue curve. It's being shaded between the flat line, guess what? Equilibrium pricing here. So the curve being equilibrium pricing and the blue curve being the supply curve. So our blue area is between these two curves. Okay, and again it's starting at it's over the interval from 0 for x to 21 for x. Okay, and so in that way, again, carefully examining our area between the two curves here, then at least in this interval between 0 and 21, between x equals 0 and x equals 21, I noticed that my horizontal line here, P equals 132.3 right here. This line is above the blue curve. Okay, and so because now we are about to set up another integral to evaluate this blue area, because integral is the only way to obtain these exact area that we're looking for right there. Okay, so now I'm gonna get out of that picture and we're gonna get back on our board right here. So consumer, this time we're heading out to producer's surplus. All right, and so now realizing producer surplus is an area. All right. We realized just now that producer surplus is an area. So let's produce that integral. It's an integral that we're going to be accumulating from 0 to 21. Okay. The upper curve this time was that flat line being 132.3. That's horizontal flat, horizontal line like that we have found earlier. And then from there I'm going to subtract the lower curve. So the lower curve was that 0.3 x squared. Okay. The lower curve was our supply curve in blue. And our supply curve is this curve right here. All right. And so now in that way, we are ready. And it's such an easy integral setup to work with. And so we don't even need to simplify our integral. And the answer at the end here gives us the producer's surplus. So that's what PS is for. Okay. And so producer surplus in this case here, or proceeding further with this integral, we're looking at the very next step here is to obtain antiderivative. So 132.3, I'm going to multiply with x, okay, and minus, now this is going to give me 0.1 x cubed, and again allow me to assume that viewers for this video lesson have already been very familiar with how to find antiderivative. So I can speed up that process here individually. And then evaluating from 0 to 21. Okay, and so the setup here comes out, the next step comes out as following. 132.3, I'm going to multiply with, substitute in 21 for every x value, for every x variable here. So 21 cubed. So that's our antiderivative evaluated at the upper limit. Okay, and now I'm going to subtract. And here we have 132.3 multiplied with 0 and subtract 0.1 multiplied with 0 cubed. All right, and so now we are ready for another final calculation. And again, allow me to quickly step away for a quick calculation, and I'll be back with that final calculation result. All right, so now I've had the final answer here with me. So that producer surplus is calculated to be the total of 1852.2. All right, and that's how we're doing it. All right, so in the end, as a bottom line here, the skill to be able to apply integral into finding an area is not only a problem to find area for fun. Area has an application right that exists right in your work in business right there. Producer surplus and consumer surplus right there. And that's the concept where we need to learn how to find areas between the two curves. Okay.